सर मी सांगतोय. हां तिथून युट्यूब कर तिथून लिंक शेअर केली प्रॉब्लेम इथून बंद केलं ना तर त्यांना पण आवाज हां याचा आवाज बंद केला तरी चालेल. याचा आवाज बंद लगेच जा म्हणा मार्गदर्शन कशाला त्याला तुम्ही सांगा.
मैंने एडमिट ऑनलाइन करूँ प्रमोट ठाकुर ना क्या
हाँ 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 ते हे करायचं कोर्स करायचं हां कोर्स करायचं अजून कोण
खरं यांना कोर्स करतो
बघा आले
प्रमोद ठाकूरनं कोर्स
मोर
सुरू झाले
मोरमध्ये मेको बस
येस येस
येस ओके आणि अजून कोण कोण
थांबा महेश बदानी
त्यांना फोन करा
त्यांना जॉईन करा
लगेच पटकन जॉईन करा म्हणजे कसं हे व्हायला तोपर्यंत
हॅलो हॅलो
ठीक आहे स्क्रीन घ्या आपली
काय झालं सर
हां सध्या नाही
बरं झालं हां हां हो जॉईन करा लगेच सर नेटवर्कचा इश्यू आहे आमचा म्हणजे तुम्हाला कोर्स करून टाकतो एक हां हो जॉईन करा आधी
काय झालं
त्यांना म्हणलं पटकन जॉईन करा
हां तर ना कोर्स करायचा बाकी जण म्यूट ऑल करून टाकायचं
आपला आवाज होते का माईक बंद करा
टेस्ट करा सर आपला माईक बरं टेस्ट करा.
हॅलो सर, आमचा आवाज येतोय का? हॅलो.
माझा आवाज येतोय का आता?
ओके सर.
नाव ऑडिएबल ना?
येस सर.
ओके फाईन, दॅट्स ग्रेट. ओके.
You are audible.
हॅलो.
Good morning to one and all. Myself Dadasaheb Arekar, on behalf of Art, Science and Commerce College Mokhada. It's my great pleasure to welcome you all in this national webinar organized by Department of Physics and Chemistry of our college on research trends in chemistry and physics. Initially, I express deep gratitude. Myself Dadasaheb Arekar, on behalf of Art. Initially, I express deep gratitude towards our beloved principal, Dr. J.J. Jadhav sir, for allowing us to conducting this webinar. This webinar came into action due to continuous motivation and support of our principal sir. Now I request to our honorable principal sir, Dr. J.J. Jadhav sir, to deliver his welcome speech.
Hello. Good morning. Namaskar. I am Principal J. Jadhav from Research Sanstha's Art, Science and Commerce College Mokhada. I warmly welcome to all of you to this national webinar on research trends in chemistry and physics, jointly organized Department of Chemistry and Physics. On the occasion of this national level webinar, I pay my tribute to the great social reformer and educationist, the founder of the Research Sanstha, Dr. Karmir Bharao Patil. He founded the Rayat Shikshan Sanstha in 1990 to educate the children of doctors. At present, the Sanstha is operating to a network of 769 branches, including 42 senior colleges. It provides education to over 4.5 lakh students through the workforce of 16,000 employees. ASC College Mokhada is one of them. I honestly think that the Karmir Anna's Rayat Shikshan Sanstha is way to remove darkness in the life of people by establishing college in a remote tribal area. In this current pandemic situation of COVID-19, Arts, Science and Commerce College Mokhada, District Palghar, Maharashtra has organized national webinar on research in chemistry and physics. This webinar focuses on this aspect of preventing measures COVID-19 pandemic, and another lecture throws light on the topic luminescence, a brief review, and thermoluminescence. Dosimetry is the very important technique to measure and determine the ionizing radiations surrounded to us. Both the topics are very useful to the general audience as well as researchers working in this field. I once again welcome all the participants to this webinar. Thank you. Thank you very much.
Thank you very much, sir, for your valuable words. It was a great pleasure for us to hear you. Thank you so much, sir. Now I request Professor A.C.
Hello, very warm and graceful good morning to all of you. I am Mr. Subhash Punde. I am very happy to introduce our first resource person of our national webinar, Dr. Mahesh Badane sir, from giving a small time in COVID-19 situation on national webinar jointly organized by Department of Chemistry and Physics. Brief introduction to Dr. Mahesh Badane sir is, sir has completed MPhil and PhD degree from Savitribai Phule University. Sir awarded Dr. T.S. Fellowship under UCLA. He is also awarded Savitribai Phule postdoctorate fellowship by Savitribai Phule University. Also work as project assistant, published more than 22 research articles in reputed international peer-reviewed journals. He also published one book chapter and attended more than 20 international conferences till the date. Luminescence, brief overview, and thermoluminescence. I request to document over to
मोबाईल आवाजचा प्रॉब्लेम आहे.
Please start your session, sir. अच्छा हो स्टार्ट करा सर. आपला आवाज येत नाही. बंद आहे व्हिडिओ.
Okay, very good morning to all. I, Dr. Mahesh Badane, working as an assistant professor Department of Physics, Dada Patil Mahavidyalay, Karjat. Now screen is in visible form. Screen दिसते का sir? Screen दिसते का? Now screen is in visible form.
Yes, sir, you are visible.
Okay, fine. Now today I'm going to discuss about the topic of luminescence, a brief overview, and thermoluminescent dosimetry. In our today's lecture or today's topic, we have to cover a topic of types of luminescence only, and later on the dosimetric properties of thermoluminescence. Okay, so main important parameters or main important key point of the today's talk is thermoluminescent dosimetry, but we will discuss before types of luminescence. Okay, so today's outline of the talk is what is luminescence, what are the types of luminescence, which type of synthesis methods are useful to develop a luminescent materials, primary studies using the characterization techniques, which of the characterization techniques are important to identify the suitable material for luminescent application, and later on thermoluminescence, and finally dosimeters. Okay, so let us start the today's talk. So luminescence, we already heard about the luminescence. What is mean by luminescence? Okay, so in every day or in our college premises, or if we attend some of the conferences, we heard the topic of or name of luminescence. So what is mean by luminescence? Luminescence is the phenomena in which substance absorb energy from some external source, and within a fraction of light emits a light. Okay, that is nothing but a luminescence. And there are two categories of luminescence. There are two classifications of luminescence. One is the fluorescence and another one is the phosphorescence. Okay, so what is the difference between the fluorescence and phosphorescence? How we can correlate, or how we can, this is the fluorescence and another one is the phosphorescence. So what is the difference between the fluorescence and phosphorescence? So fluorescence is the spontaneous emission of light. Getting my point? Fluorescence is the spontaneous emission of light. It means there is two bands, conduction band and valence band. Okay, and whenever electron is stimulated from the ground state to the excited state, and they excite from excited state to the ground state within a fraction of second. Okay, means that time is less than 10⁻⁸ second. Okay, and typical lifetime of that electron day excite, the time is the 10 nanosecond. That is nothing but a fluorescence. And what is meant by phosphorescence? What is meant by phosphorescence? The difference between the phosphorescence with compared to fluorescence is the delay emission of light. Okay, so inside the phosphorescence material, there is some metastable state was occurred. There is some metastable state was obtained. Okay, and how that metastable state was created? With the help of doping, with the help of activator, with the help of some of the impurity. That metastable state, or we can say a trapping level. Okay, that trapping level or metastable state was occurred. Okay, so delay emission of light, due to that metastable state, the light emission was delayed, or and that light emission delay up to typical lifetime is millisecond, up to second, or days, or sometimes 10⁻⁴ year also. Okay, 10⁻⁴ year also, and it is a temperature dependent phenomena. It is a temperature dependent phenomena. Means if we want to recombine the electron from the metastable state, there is required some of the temperature. But in case of fluorescence, there is not required a temperature. Within a fraction of second, that emits a light. But in case of phosphorescence, there is required some kind of external energy to recombine the electron from metastable state. Okay, so luminescent material is nothing but a phosphor material. Okay, so in the area of phosphorescence, phosphor is nothing but a what? Generally inorganic solid like insulator, semiconductor, having a some kind of band gap. Some kind of band gap is nothing but a large band gap or small band gap. If we consider semiconductor, so less than 3.6 electron volt, that is the semiconducting material, and above 3.6 or 4 electron volt, that is the insulator material. Okay, and if there is some band gap, then there are some trapping levels or energy states was generated. Okay, so this is the fundamental of and classification of luminescence. Okay, so these are the types of luminescence. Types of luminescence means photoluminescence, photoluminescence, bioluminescence, thermoluminescence. These are the types of luminescence. Okay, and we will cover that types in the form of sub definitions. Okay, so we will discuss about the types of luminescence. So what is meant by bioluminescence? What is meant by bioluminescence? Some of the living organism emits a light is nothing but a bioluminescence. Okay, so one of the famous example of bioluminescence is the fireflies. One of the fireflies. It means whenever we are visit some of the darkest area or in the forest area, that time we can see the fireflies attracting a female with the lid up behind. Okay, that fireflies was shy some of the light. Okay, shining some of the light, or one of the mushroom glowing just some of the light. These are the types of luminescence. Okay, some of the ocean entities, like some of the biological entities like bugs, fireflies, denizens, on the deep like anglerfish. This type of example of bioluminescence. Okay, so these are the examples of bioluminescence. Now move towards the cathodoluminescence. Okay, so cathodoluminescence is what? Some of the gaseous, okay, so or some of the emission of light which material excited by the electron beam. Okay, emission of light by exciting a material by using the electron beam. That is nothing but a cathodoluminescence. Okay, during the irradiation time by using this electron beam, or if we put our material onto the scanning electron microscope, that time electron beam was bombarded onto the material, and that time some of the material was shine, or that type of light is nothing but a cathodoluminescence. The beam of electron is usually formed in an electron microscope or scanning electron microscope. I already spoke. Okay. Now next example is the chemiluminescence. Okay. Next type is chemiluminescence, or some of the chemical reactions that time emits a light. Okay, that is nothing but a chemiluminescence. Luminescence excited by chemical energy called chemiluminescence. It is a conversion of chemical energy directly into the light as a result of chemical reaction. Okay, so these are the some of the chemical, and if we shut down the light, that time that chemical was emits a light. Okay, that chemical was shining that time. Okay, so if we consider a cadmium sulfide or a cadmium telluride or a uh, cadmium sulfide material, so that type of chemicals also emits a light. Okay, so this is nothing but a chemiluminescence. Okay, now the another example is the electroluminescence. Okay, so what is the type of electroluminescence, or what is meant by electroluminescence? So electroluminescence is caused by electric field. Okay, or some of the gases emits a light when electric current pass through them. Okay, so that time light was emitted. Okay, it is used in an automobile dashboard to illuminate a car's meter. Okay, or some of the watches are also available in the market, that type of electroluminescent materials which is made. Okay, so this type of electroluminescence, this is the figure of electroluminescence. Okay, so next example is the triboluminescence, or is the synonyms of triboluminescence is nothing but a mechanoluminescence. Okay, so how triboluminescence was happened? Okay, so triboluminescence is nothing but some of the substance was ruptured and fractured. That time the light was emitted. Getting my point? So it means if we consider two stones and struck together, and that time some of the sparking was happen. Some of the spark was happen. That is nothing but a triboluminescence. Or another famous example is the when we chew a sugar and sugar particle experiences mechanical pressure between teeth. Okay, and as a result, a large number of bonds break and which turns emit a light. That is nothing but a triboluminescence or mechanoluminescence. This is okay. So let us consider another example, that is radioluminescence. Okay, so what is meant by radioluminescence? Radioluminescence is generated when some material are exposed to ionizing radiation. Okay, or if we consider as if we put our sample or material or any kind of phosphor material in front in the surrounding of radiation, like electron radiation, ion beam radiation, or gamma radiation, and if we bombard that radiation onto that material, that time that material emits a light automatically. Okay, so that type of luminescence is nothing but a radioluminescence. Okay, so radioluminescence is known as scintillations. Scintillation means if we coat some of the phosphor material onto the filament, and if we bombard a radiation onto that filament, that time light was emitted. Okay, this is the famous example during the radiation time. Okay, so another type is photoluminescence. Okay, so what is meant by photoluminescence? What is meant by photoluminescence? Photoluminescence is the emission of light due to the excitation by sound wave, including ultrasonic wave. Okay, if we keep beaker into the ultrasonication chamber and continuously sonication was started, that time some of the bubbles was developed. Okay, and that circle portion indicates a in terms of light. Okay, so sonolumination is nothing but a emission of light due to the excitation by sound waves, including ultrasonic waves. Okay, in the latter case, the emission of short rupture of light from crashing bubbles in a liquid when excited by sound. Okay, so that time sound luminescence was happened, or that light was emitted. Now the very important type is nothing but a photoluminescence. Okay, very important type is nothing but a photoluminescence. So photoluminescence is nothing but a spontaneous emission of light upon electronic excitation is called a photoluminescence. Or okay, so inside the photoluminescence there are two states was generated. One is the valence band and another one is the conduction band. Okay, so conduction band is nothing but an excited state. We can consider an excited state. Okay, and the valence band, always electron is present inside the valence band. Getting my point? So, and there is some electronic states was present, and that electron states, or we can say metastable state, or we can say trapping levels. That states was generated due to the effect of doping, activators, or defects level. We can say defects level. Okay, so these are the types of photoluminescence. So how photoluminescence was happened? The spontaneous emission of light upon electronic excitation is called photoluminescence. I already spoke about the definition. But some of the photon energy or some of the external energy was bombarded onto the phosphor material. That time electron was stimulated to the and goes to the excited state. Okay, from valence band to the conduction band, and again trapped to the metastable state where the trapping level was generated. This is the metastable state. We can say this is the metastable state, or we can say that the trapping level or energy states. Okay, this is the metastable state. Okay, and within a fraction of second or greater than 10⁻⁸ seconds, again that electron was de-excited and comes to the valence band, and at the same time light was emitted. That is, and that light is nothing but a luminescence photon. Okay, or that, and when light was emitted, that is nothing but a photoluminescence. Okay, so this is the nothing but a photoluminescence. Okay, so this is the animated videos I will explain here. We can say this is the valence band, and above is the conduction band, and some of the light was coming to the and at the same time electron was excited and goes to the conduction band, and again comes to the metastable state and they excite, and that at the same time light was emitted. Okay, so that is nothing but a photoluminescence. Getting my point? So move to, so what is meant by photoluminescence? Okay, so photoluminescence is a material that emits a light is called luminescent material. Okay, keep in your mind that only phosphor materials are used in the case of photoluminescence. It may be a semiconducting material or it may be a insulating material. Okay, so how phosphor name was came? So Greek word phosphor is nothing but a Greek word. It means a light bearer. Is usually used to describe luminescent nature. Okay, it emits energy from excited electronic state as a light. Okay, so this is nothing but a photoluminescence. Or what will happen exactly? Some of the incident energy is absorbed and re-emitted as a light of a longer wavelength. Okay, it means from valence band to conduction band, electron was excited and goes to the conduction band. Again, they excite and struck to the metastable state and again goes to the valence band. Okay, and at the same time, light was emitted. That is nothing but a photoluminescence. The emitted light carries the material signature. So, what is the applications? Okay, and which kind of materials are useful to study the photoluminescence behavior? Okay, so these are the chart indicates a material. This is the materials which is already developed, and these are the band gaps. Okay, so the star indicates. I have makes one symbol here. That star indicates. Okay, that star indicates what? In our college level, in bachelor degree time or college level, we somebody asked us the question, what is the semiconductor material means for which material? So we easily tell him or her that the silicon or germanium. And again, next question is what is the band gap of silicon and germanium? So we easily spoke him or her that the germanium having a band gap is near about 0.7 electron volt and silicon is the 1.1 electron volt. Okay, these are the light emitting materials: germanium, indium, indium arsenide, indium phosphide, gallium arsenide, gallium tin, cadmium selenide, cadmium telluride, zinc oxide, zinc sulfide. These are the famous material. Okay, to study the photoluminescence behavior. Okay, this data was taken from one of the famous book, that is the Introduction to Solid State Physics, which is written by the C. Kittel. Okay, and that table was taken from this book. So, what is means by what are the where is the application or photoluminescence used for which areas and why photoluminescence is important? Okay, why photoluminescence is important to study? Okay, so photoluminescence is important to technique for measuring the purity and crystalline quality of semiconductors. Okay, by using the photoluminescence, we can determine the purity of the material or crystalline quality of the semiconductor material. Okay, if there is some defects or if there is some defects or impurity, so we can easily identify or we got some of the PL spectra or emission spectra at the same time. Okay, and the next sentence indicates using the time resolved photoluminescence, that is nothing but a TRPL, one can determine the minority carrier lifetime of semiconductor like gallium arsenide. Okay, so semiconducting material is very much important in the area of long lasting light emitted. Okay, or LED purpose applications. Okay, so what is the band gap of gallium arsenide? That is the 1.44 electron volt. That is the band gap of gallium arsenide material. Okay, so can be used to determine the band gap, exciton lifetime, excitation energy. These are the application or these are the usefulness of photoluminescence material. Okay, so next. Now our main area is the thermoluminescence. Okay, so let us start the thermoluminescence dosimetry. Okay, still now we are covered the thermoluminescence types of luminescence only. Now from next slide or from here we will cover a thermoluminescence dosimetry, which is my interested point or which is my interested topic, which I have did lots of research in the area of thermoluminescence dosimetry, or we can say that I'm a familiar with the thermoluminescence dosimetry. Okay, so what is meant by thermoluminescence, or what is the definition of thermoluminescence? Thermoluminescence is the phenomena of light emission during warming a previously irradiated substance with uniform heating rate. Previously irradiated substance means what? There is required some of the ionizing radiation to excite an electron from ground state. Okay, it means there is required some of the energy, or that energy in the form of ionizing radiation. Or ionizing radiation is nothing but a alpha, beta, gamma. Okay, or we can say ion beam, neutron. These are the ionizing radiation, or that type of ionizing radiation is required to stimulate a electron from ground state to excited state. Okay, or that type of ionizing radiation is required to excite the electron from ground valence band to conduction band. Okay, now this here one of the figure I will explain to for the better understanding. Okay, so here A, B, C, D, E, F, these are the figures indicates, and here stage 1 indicates energy stored. Stage 1 is nothing but energy stored, and stage 2 indicates a energy release. It means in stage 1 case, that time whenever ionizing radiation was exposed to that particular phosphor material, at the same time valence band from the valence band electron was stimulated and trapped to the metastable state. Metastable state. Okay, so figure A indicates the pure material. We can say that pure material. Okay, there is no ionizing radiation was exposed. Okay, there is no bombarded of any ionizing radiation. Okay, so if in B figure indicates if we bombard or if we expose our material from any of the ionizing radiation, at the same time electron was stimulated and comes to the metastable not a metastable state, conduction band, and trapped to the metastable state, which is given in the figure C. Okay, and that electron was stay or trapped up to greater than 10 to minus 8 second, or maybe second, or maybe hour, or up to 10 to 4 year. But when that electron recombined to the recombination center, or again valence band, if we did not apply any external energy or heat, so that electron stay at this same portion. Okay, or that electron was stay in the metastable state as it is. In stage 2, okay, what will happen here? Here we look at here, this one. Here we apply heat. Okay, what is the definition indicates? The thermo means heat and lumens means light. Here we apply heat, at the same time from the metastable state was electron was de-excited and comes to the ground state. Okay, figure E indicates. At the same time light was emitted, and that light was emitted and finally we recorded some of the TL spectra, and that TL spectra we can record by using the thermoluminescent reader. Okay, I hope that you might be clear from that figure. Okay, so again I will explain one of the very interesting figure to better understand. Okay, this is the valence band, this is the conduction band, and here is the exposure. Okay, here if we, this is the sample. Okay, we can say this is the phosphor material, or we can say this is the TL material or thermoluminescent material. Okay, or if we exposed, okay, if we export by any ionizing radiation for that material, that time that radiation was absorbed. And if we did not apply any thermal energy, that radiation was stored in that particular material. Okay, that's why here some watch was indicate. Okay, that radiation was stored up to how much time? Up to 10 to 4 year. Depends on the fading. Okay, depends on the radiation loss per unit time. Okay, and next figure indicates if we apply heat at the same time, there from the metastable state electron was stimulated and de-excited to the ground state. Okay, at the same time light was emitted. Again, I will explain one of the figure. Okay, electron goes to the conduction band and again comes to the recombination center. At the same time, light was emitted. Okay, so now what is meant by dosimeter? What dosimeters are important. Okay, and why this topic is very much important to us? Because this topic is very much useful because of the maximum allowable dose is limited to 20 millisievert per year for people working with radiation. Okay, those people who was working in the area of radiation, so his limited dose rate is what? 20 millisievert. Okay, sievert is the unit of dose measurement. Okay, and this limit is 1 millisievert for the normal population. Okay, because what? We are totally surrounded by radiation. Okay, some of the non-ionizing radiation or some of the ionizing radiation also. Getting my point? So that we are totally surrounded by the radiation, and this is the very important tool to determine, to detect, to measure the radiation. Right? Okay, dosimetry is very much important tool. Okay, why it is a crucial to perform measurements on the radiation generators used to diagnostic or therapeutic purposes. Okay, this is the very important tool in the area of the medical application purposes, environmental application purposes. We will discuss later on. Okay, so dosimetry is very much important tool. Thermoluminescent dosimeter is a type of radiation dosimeter. Okay, so my point is what? Who is the pioneer? Okay, who is the pioneer of thermoluminescence? Okay, and the phenomena of thermoluminescence was used for the dosimetric purposes around 50 years back. Getting my point? This phenomena was purposed around 50 years back, and this application was suggested by the American scientist, one of the famous scientists, who is suggested this kind of application. Okay, their scientist name is what? F. Daniel. Okay, till various phosphors have been developed. Okay, there are various phosphors was already developed. Okay, there are various phosphors are already developed and are used in a application of personal dosimeters, personal monitoring, environmental or medical dosimetry applications. It should be noted that TL dosimeters are increasingly accepted for radiation dosimetry due to several reasons, and that reasons I will explain in our next slide. Okay, so these are the radiation sources. These are the radiation sources which is very well acceptable by the international systems of units. Okay, so radioactivity which is measured by bicural. Okay, and we are talking about the absorbed dose. Okay, we are talking about the absorbed dose. Okay, means our thermoluminescent material was absorbed dose, and it will store up to maximum period of time. Okay, and we can measure it after a few days or after 6 months or after the some of the days. Okay, so we are taking this type of units to measure a absorbed dose. That is the gray. Gray is the famous unit to measure a absorbed dose, or RAD. RAD is nothing but a radiation absorbed dose. What is the full form of RAD? That is nothing but a radiation absorbed dose. Okay, these are the some of the conversion formula or conversion unit. 1 curie is nothing but a 3.7 into 10⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻⁻ material or particular radioactive material. So this kind of materials are used, or this type of unit are used, not a material. Sorry, this kind of units are used. Okay, so let's move in the next slide. Okay, so the measurement of radiation is called dosimetry. Okay, I will already explain to measurement of radiation. The measurement of radiation is called a dosimetry, and the equipment used for dosimetric procedure is called dosimeter or detector. Okay, and now we are measuring a radiation by using the thermoluminescence dosimeters. Okay, so what are the accepted radiation dosimetry? These are the important parameters. Oh, these are the important thermoluminescent parameters. Due to that parameters, this is very well acceptable in international levels. Availability of tissue equivalent thermoluminescent materials. Because why availability of tissue equivalent material? Because why this kind of this sentence indicates because our body is fully made up of tissues. Okay, maximum amount of water was present in our human body. Okay, because and if we calculate the tissue number of our body, so that number comes around 6.4. Okay, because our body number of maximum amount of water was present, means H2O was present. Okay, and due to that reason, if we develop a dosimetric material, so some kind of tissue materials we have to develop. Okay, the second sentence indicates sufficiently high sensitivity and accuracy. This is very sensitive material. This is the very sensitive technique to easily detect, to easily absorb a radiation. Okay, availability of small size detector adaptable for different applications. Okay, we can make a particular size of TL materials. Okay, 5 mm diameter TL dosimeters are also available. 1 centimeter diameter dosimeters are also available. 1 mm. Okay, keep in your mind 1 mm size of dosimeter detectors are also available in the market. Okay, another one is the availability of materials with excellent long-term stability under varying environmental condition. Okay, so the radiation was stored up to maximum period of time in the environmental condition. Okay, there is no affected in the environmental behavior. Okay, like inside the environmental there are gaseous molecules are present, there are thermal temperature are also present, humidities are also present, and that kind of effect what does not affected onto the thermoluminescent material. Good sensitivity, reusability. Okay, we will discuss also in further slide. Okay, so dosimetric properties of TL phosphor is what? Easy to prepare, should possess simple glow curve structure. Simple glow curve structure means what? Finally, whatever TL emission spectra was observed, at the same time, we will detect a TL glow curve spectra. Like Gaussian glow curve we was obtained, Gaussian glow curve we was recorded, and that time we are say that simple glow curve structure was necessary required, or we can say that the single glow curve. If there is single glow curve was present, it means that there is trapping level was in a single trapping level was generated. Okay, it means single metastable state was developed inside the conduction band and valence band. Okay, another one is the chemically stable and under the extreme climatic condition, nearly tissue equivalent, simple annealing procedure for reuse. Okay, if this sentence is very much important, simple annealing procedure. Okay, this sentence is very much important because if some of the TL phosphor material was absorbed the radiation. Okay, and if we recorded that TL dosimeter, or if we recorded radiation dose, after that we can't throw that TL phosphor material. We can reuse that material. Okay, there is not necessary to throw that material. Okay, if we anneal up to particular temperature level, that is nothing but a 300 to 400 degrees Celsius. So all the trapping levels was diminished or vanished. Okay, means inside the trapping level that metastable states was killed. Okay, so it is, so that type of material we can reuse again and again. Okay, and most important property was it should not be expensive and non-toxic. Okay, we can develop in very low cost also, and we can buy that dosimeters in very low cost and non-toxic. Because there is a very much important property, non-toxic, because we are a researcher, and if we develop that type of dosimeters and during the developing time, development time, if that material was affected in our body, so it is very much harmful. Okay, so keep in your mind that during the preparation time, you have to choose a non-toxic material. Okay, so these are the properties or requirement of TL material. We will move to the next slide. Okay. Okay, so in this table indicates that these are the main TL phosphor materials is used in a radiation dosimetric application purposes, which is already developed TL phosphor material. Okay, so TLD 100 is nothing but a what? This material was primarily developed. Okay, in the universe, this material was primarily developed or first time developed lithium fluoride material having a tissue equivalent number is 8.2. If tissue equivalent number is 8.2, there is some formula. Okay, those who are required this formula, so I will share you on that mail separately. Okay, so this is the tissue equivalent material. Okay, and in our body, tissue equivalent number is nothing but a 7.4. Okay, and if we calculate the lithium fluoride material, so tissue equivalent number is near about 8.2. It is quite related to our body. Okay, because our body is fully made up of tissues. Okay, so number second is what? There are some dopant was some of the material was doped inside the lithium fluoride material. Okay, TLD 100H. Okay, and then sensitivity was little bit increases. Okay, this is the dose range. This is the suitable dose range. Okay, this is the suitable dose range, and that particular dose range we can use that particular thermoluminescent material. Okay, then lithium fluoride TLD 200. After that, TLD 400 was developed, 500 was developed, and TLD 900 was developed. So this is the standard number. Okay, and that standard number indicates that particular TLD material. This TLD material is nothing but a TLD 900. Okay, and this name was given by an international community. Okay, that is TLD 900. Okay, having a dose range response is nothing but a 100 microgray to 100 gray. Okay, and feeding rate is 2% in 1 month and 8% in 6 months. Feeding is nothing but a radiation loss per unit time. Okay, and this is the tissue equivalent number. Okay, so I will erase this explanation here. Okay, so in our next point, I will cover here. These are the recently developed TLD materials. Okay, or I will skip some of the point here due to time constraint. Okay, in our previous slide, what will happen? All the dose range is near about 100 gray, or maximum dose range is around 1 kilo gray. TLD 800 material indicates a dose range response from 0.5 milligray to 1 kilo gray. Okay, but sensitivity is very less. Okay, and these are the recently developed TLD materials. Okay, nanophosphor material goes up to 20 kilo gray. Okay, and traditional phosphor means primarily developed phosphor material indicates a 10 gray. These are the recently developed TLD materials. Okay, which was the data taken from. This is the literature where we have I have taken this data. Okay, now which type of characterization techniques was important and which type of synthesis methods are important to develop a thermoluminescent phosphor material. This is the chemical co-precipitation method. I will explain here. This is the chemical co-precipitation method. By using the chemical co-precipitation method, we have to develop a phosphor material. Okay, this is the hydrothermal method. Okay, by using the simple route of hydrothermal method, we can prepare or we have to develop a phosphor material, or that is thermoluminescent material. This is the acid recrystallization method. If we are planning to develop a micro material, so this is the suitable method to use a acid recrystallization method. Or if we are planning to develop a nano material, so this is the methods: hydrothermal method and co-precipitation method. Okay, so we'll move towards the co-precipitation characterization technique. Okay, so primarily characterization technique purposes, X-ray diffraction technique was very much useful to determine a crystalline site. Okay, to determine a crystallite size, X-ray diffraction techniques was very much useful, because without X-ray diffraction, we can't say this is the nanomaterial or micro material. Okay, or which phase was formed of our developed material. This is the technique to determine a phases also. Okay, so what is the band gap of our developed material? This is the technique to determine a band gap purposes. Okay, so UV ray or UV visible spectroscopies are also much useful technique. Another one is the scanning electron microscope. Okay, so morphological behavior we can determine by using the scanning electron microscope. Means our developed material how look like. Okay, it is a nano rods was present, or tube-like structure was present, or cuboid-like structure was present, or any other type of morphological behavior was present. By using the scanning electron microscope, we can determine. Okay, so photoluminescence also one of the technique. This is the instrument, and last one is the what? Thermoluminescence recorder. This is the TL reader. Okay, this is the TL reader, and this is the thermoluminescence reader. Okay, the model number is 1009I. This is the entire setup of thermoluminescent reader, which is available in Pune University or our samsthas, or we can say various institute. Also, this kind of techniques was available, and those who are interested to do work in the area of thermoluminescence reader, they can contact with us. Okay, this is the TL reader. Okay, so these are the irradiation facility you can use to irradiate our sample, or we can irradiate to your sample by using the different techniques. This is the cobalt 60 gamma source, which is located in the Pune University. This is the 6 MeV race track microtron oscillator, which is also available in the Department of Physics, Savitribai Phule, Pune University. Okay, this is the thermal neutron source. Okay, which is also available in the Pune University, and this is one of the irradiation facility, that is low energy ion beam facility, or swift heavy ion, which is located in the IUAC New Delhi. Okay, or those who are interested to do work in the area of thermoluminescence, you can contact me directly to our mail. Okay, so I will suggest you. Okay, so I will explain our paper and then stop to our today's lecture. Okay, so I have choose here Californium, sorry, not Californium, calcium fluoride dysprosium doped material. Okay, so primarily TLD 200 material, that is CF2 dy doped material, indicates a 10 milligray to 100 gray only. But by using the particle size dependent TL response, or by using the ball milling method, we have expanded our material, the dosage response up to 1 gray to 12 kilogray. Okay, so in this article, what we have did to reduce a particle size, by using the ball milling method. I will explain in our next slide. Okay, so this is our recently published article, and we have received very good citation also, because this is the unique what we achieved. Okay, this is the collaborated with the Professor Dhole sir, Professor P.S. Patil sir from Kolhapur University, Professor Dhole sir from Pune University, Voraskar sir, More sir, like very much eminent personality. Okay, so how we can prepare? This is the we have used a two-step method here. Primarily, we have used chemical co-precipitation method. Okay, primarily we have used chemical co-precipitation method, and for that purposes we have choose calcium chloride and ammonium fluoride chemicals, and doping purposes we have used Dy2O3 material. Okay, and after the preparation of calcium chloride material, we for the size reduction purposes we have choose a high energy ball milling method. Okay, and the ball milling time scale was varied up to different hour, 1, 3, 5, 10, 15 up to 50 hours also. Okay, so I will share one of the animated video here. I will how to reduce the particle size. Look at here carefully. How particle size was reduces. Okay, and how the this method was very much useful to reduce a particle size. Okay, so this is the animated videos. Look at here carefully. And finally, we got a nanoparticle material. Okay, so always high size particle material shows a high sensitive behavior in the area of thermoluminescence, but the dose range response is very less. Okay, below 100 gray, or we can say below 1 kg. But if we reduce a particle size, then we got a high dose range response. So in X-ray diffraction, we can say as prepared sample indicates a very less FWHM. And if we look here in the 50-hour ball mill sample, we got a crystallite size is around 10 nanometer. Okay, and FWHM is also increases. And second figure indicates a how to decrease a particle size, or not a particle size, here crystallite size, how to reduce the crystallite size. Okay, so we also confirm by using the JCPDS card number, that is 772242, and the structure shows a cubic structure having lattice parameter is face centered. Okay, and if we calculate a average crystalline size for pristine sample, that is 38 nanometer around. Okay, we also confirm by using the FESAM for the purpose of size determination or morphological behavior purposes, and we got a particle size maximum around 30 to 40 nanometer for 50-hour sample, and we got a particle size is around 150 to 100 nanometer for pristine sample. Pristine sample means what? 0-hour milled or prepared by using the chemical co-precipitation method. Okay, these are the histogram indicates their particle size or average particle size behavior. Okay, we also confirm by using the transmission electron microscope also. Okay, I will skip here due to time constraint. Okay, so we also observed the absorption behavior by using the UV absorption spectroscopy. So interaction between the UV light and particles can be due to the increased surface area with size reduction. Okay, and here some blue shift was obtained if the size reduction was happened on that particular particle or particular material. Okay, we also obtained or observed by using the thermogravimetric analysis, and in here we observed some of the weight loss. Okay, 0-hour sample shows 0.67% weight loss for 400 annual sample, and here D sample means 35 nanometer. 35 nanometer indicates a 50-hour ball mill. Okay, so this sample shows 1.12% weight loss. Okay, this is the thermoluminescence spectra. Okay, this is the primarily irradiated. Before the ball milling time, we have irradiated the sample. Okay, and we got a such kind of spectra. Before development of our phosphor material, we have annealed this sample for different temperature, and we got the very magically behavior. Okay, and we got a highly sensitivity for that 400 degrees Celsius, and then we choose that annual sample material for further analysis. Okay, further analysis purposes we have choose, and after that we also erase the shallow traps. Okay, so this is the A figure indicates a shallow trap, and B indicates after the reduction of shallow traps. Okay, and after that we have increases different dose rate. We have bombarded gamma radiation onto that phosphor material and recorded the TL spectra, and we got the up to 750 gray, 1 gray to 750 gray. The dose response was in a linear form, means this kind of material is useful in the area of 1 gray to 750 gray, and further it will get saturation level. Okay, so we have choose this material for further analysis. Then after that, what will happen? We have used a ball milling technique to reduce a particle size. Okay, this particle size is around 150 to 100 nanometer. Okay, this is the pristine sample, and later on we have used different particle size sample. Okay, so if this is the figure indicates a 0 hour to 50 hour sample. How sensitivity was decreases? This is the 10 hour sample and this is the 50 hour sample. So in the 10 hour volume sample shows a dose range response up to 1 gray to 12 kilogray, and here there is no showing any linearity. Okay, means there is a linear and supralinear behavior was obtained. So we can say that 10 hour ball mill sample or 65 nanometer particle size sample shows a good dosimetric behavior. Okay, good dosimetric behavior. So let's move to the next slide. So this is the dose range response, and finally we achieved a 65 nanometer particle size sample shows a 1 gray to 12 kilogray, having a slope is around 0.982. Okay, that is the slope of that particular dose response. This D spectra indicates a 65 nanometer sample. Okay, and the same material which is developed by primarily standard TLD material, we can say TLD 200. That material shows a 10 microgray to 10 gray. But now we have developed our material up to 1 gray to 12 kilogray by using the decreasing a particle size. Okay, so we have also put our sample onto the cancer patient and also recorded we have observed this experiment in the command hospital, which is available in the Pune. Okay, the radiation experiment were performed using the gantry or pencil type cobalt 60 gamma source, which is located at command hospital, military area, Pune camp. Okay, we have put our sample. This is the circle portion indicates our sample, and then that cobalt 60 radiation was bombarded onto the cancer patient. Okay, this patient was suffered from chest cancer, and this patient suffered from mouth cancer. Okay, and we have recorded our data, and we got very sensitive result also. Okay, so how TLD batch was developed? This is the TLD batches. Okay, those who are continuously working in the area of radiation, like cancer patient diagnosis time, the doctor will also use this kind of TLD badges. Okay, this is how we can say this is the TLD material which is developed by scientists, or we can say which is developed by us also, our community also. Okay, now at the present case, 40,000 radiation workers are covered with TLD monitoring. Okay, so that the thermoluminescent dosimeters are very much useful in the area of radiation, medical application, medical dosimetric purposes, personal monitoring purposes, environmental purposes. Nowadays, some of the reactors was blast at the same time continuously radiation was exposed. That time some of the high radiation high radiation absorbing dosimetric material was needed. Okay, so at that time, or we can say food irradiation purposes, at that time high radiation dosimeters are useful up to 20 kilogray, or we can say up to 80 gray. Okay, so this is the small radiation monitoring devices worn by person entering environments that may contain radiation. Okay, so whenever doctors are visited into the radiational area in the during the diagnosis time, okay, during the diagnosis time, we will doctor are take that dosimeters continuously. Okay, but don't forget to enter without dosimeter, because we can't see the radiation by our naked eyes. Okay, whenever we have to visit the hospital or radiational area, we have to keep the dosimeters. This or dosimeters means this type of TLD dosimeters are available. Okay, or we can say this type. If we forget the radiation dosimeters to keep inside, so we can another type of dosimeters are also available. Bracelet type dosimeters, watch type dosimeters. Okay, means we can't forget if we use this type of ring dosimeters. Okay, even ring time dosimeters are also available in the market. Okay, so now they stop here. So thanks once again for giving me opportunity to community of Mokhada College. Thank you very much.
Sir,
If there is some questions, so welcome.
Yes, sir, we have one question.
Okay, sir, welcome.
Dr. Gade sir asked, what is the relation between trap depth and thermal trap depth of any OSL phosphor?
Trap depth and sorry, pardon? I'm not getting the question.
What, sir?
Sir, your sound was not audible, sir.
Sir, question is in chat box, sir. You can see.
Where is this one? There are various charts are available actually.
Sir, another question is how to calculate the cumulative dose for telecobalt therapy?
Yes, very good question. Actually, this is the personal monitoring purposes. Bhava Atomic Research Center, whenever we have to develop a dosimeters, we have to send that dosimeters for the personal monitoring purposes to the Bhava Atomic Research Center. And they have taken the limitations, dose range response, or they have taken the priorities, or we can say that they have take all the efforts for the measurement purposes, means that is suitable for medical purposes, or that is suitable for diagnosis purposes or not, because in laboratory area there is not an suitable systems are available, or we can say that we can compare with the standard TLD material as well. Okay, so if there is TLD 100, that is primarily available material, was very much useful in the area of medical diagnosis purposes. Okay, so we can compare with that TLD 100 material with our sample. Okay, so we can tally, or we can compare with that material and personal monitor by using that system also. I hope that might be clear.
Thank you, sir. Thank you so much. Sir has given very nice information and valuable information about luminescence and thermoluminescence dosimetry, and also about dosimetric properties of TL phosphor. Thank you, sir. Thank you so much, sir.
Thank you so much, sir. Thank you.
Over to Arekar, sir.
Thank you, Kunde sir, and thank you, Dr. Bhadane sir, for your valuable lecture. Now, I would like to request Dr. Arkikodu madam to introduce second research person, Dr. Arkikodu madam.
It's my immense pleasure to introduce today's second resource person of our national webinar, Dr. Pramod Thakur sir. Sir is the Assistant Professor of Department of Chemistry, Mahatma Phule Art Science, Commerce College, Pune. Sir has qualified various national and international level exams like NET, GATE, as well as JEE. Sir has completed PhD degree from CSI Institute of IICT Hyderabad. Now, Sir is recognized PhD guide of University of Mumbai. As per teaching and research experience concerned, Sir has 8 years of teaching experience and 10 years of research experience. Sir, actively involved in the research. Sir has 5 patents to his credit. He has also published 24 research papers in well-reputed international peer-reviewed journals with high impact factor. As per awards concerned, Sir has awarded 2 national research fellowships. He has also received 2 times gold medal under Avishkar Research Convention for Best Teacher. Now, this eminent scientist as well as best teacher is going to deliver lecture on the topic chemistry in the context of preventive measures of COVID-19. Now, I request Dr. Pramod Thakur sir, please start the session. Thank you. Thank you very much.
Yes, thank you, madam, for your kind introduction. Am I audible?
Yes, sir.
Okay, so I would like to keep my video off. You permit because of the connection problem. It will be better audible if I keep my video off. So if you permit me, I will go ahead with my video off. So today's national webinar organized by Department of Chemistry and Physics, Arts, Science and Commerce College Mokhada, District Palghar. The topic of my talk is chemistry in the context of preventive measures of COVID-19. So have you got my screen? Just confirm so I can proceed.
Yes, sir.
Yes. Okay. Thank you. Yes. Yes. Thank you. Thank you very much. So I'm going to discuss the chemistry perspective in the context of preventive measures of the COVID-19. So we know that this word COVID-19 is now familiar to each and everyone. We are stuck in our homes because of this coronavirus. So I'm going to discuss the chemistry behind the various preventive measures which are suggested by the WHO to avoid the infection of this coronavirus. So before we learn what is the chemistry behind these preventive measures of COVID-19, we must understand the detailed structure of this coronavirus. So the coronavirus, also known as a SARS-CoV-2, this structure is now well familiar with each and everyone. Even my 3 years baby can easily recognize what is this, and he can immediately say, this is coronavirus. So now this is not unknown to anyone in the world. This is a small, nearly 150 nanometer molecule has stopped the whole world for this year 2019 and 2020. This is supposed to be spread from the Wuhan city of China, and he has till now infected more than 20 million people throughout the world. As far as India is concerned, more than 2.3 million people have been infected with this coronavirus. And this coronavirus pandemic, in the history of country, we have forced the national lockdown, and which has infected many peoples in the country, and it is have also the loss of more than 20 trillion USD to the Indian economy. So we can imagine the impact of this small 150 nanometer virus on the whole world. So if you understand the structure of this coronavirus from the chemistry point of view, then it will be very easy to understand what is the chemistry behind these preventive measures to avoid this coronavirus infection. So we will see the detailed structure of this coronavirus from chemistry point of view. The coronavirus structure showing the spikes that form a crown like the solar corona. Hence, it is named as a coronavirus. So here, if you see the structure, it is known as a coronavirus because you can see the crown, which is like a solar corona. If you see the cross-sectional view of this coronavirus, then we can easily observe there are four main parts of this coronavirus: the yellow color part, blue color, red color, and purple color. So the yellow color part is known as a spike glycoproteins S. Inside the coronavirus, there is a pink color part which is known as the RNA and N protein. The red color part is the envelope, which is very important part of the coronavirus. We can say this is the shield of a coronavirus. And the small blue color part, which is a hemagglutinin esterase dimer. So basically this coronavirus consists four different parts, and these four different parts are important to him. we are going to see each of this part in detail from the chemistry perspective. So the first part, this is the a detailed photograph or actual photograph of this coronavirus, which is taken by the transition electron microscope technique, which shows the SARS-CoV-2 virus that causes COVID-19, which is isolated from the patient in the United States. So this atomic level structure of this SARS-CoV-2 spike proteins have been well recognized and it is well understood. And this was taken by the technique called cryo-electron microscopy. This cryo-electron microscopy take the detailed picture of the structure of the spike protein, and it was the important development in the COVID-19 research to identify the structure of spike protein, which have helped to develop the vaccine, or it will be very helpful to develop the new medicines to treat the COVID-19 patient. So that was the important achievement. The next part, which is a spike glycoprotein, we will see from the chemistry's perspective. So as we seen in a cross-sectional area, the yellow color part is a spike glycoproteins, but you look it more closely from chemistry's perspective, you can observe that these spike glycoproteins are the proteins which are attached from oxygen or from nitrogen to the sugar molecule. So these spike glycoproteins are O-linked or N-linked amino acids which are attached to the sugar molecule. The second part is the RNA and N protein, which is present inside the coronavirus. So this pink color part, which is a RNA and N protein, if you look more closely from chemistry's perspective, then we can understand this RNA is nothing but a chemical molecule in which the heterocyclic base is attached to the pentose sugar, which is attached to the phosphate molecule. So this linkage of the three molecule is known as a RNA, and this type of structural framework is present inside the coronavirus. So N protein is nothing but the biomolecules of amino acids. So this type of structures are present inside the envelope of coronavirus. So from chemistry point of view, we can understand that what is present inside the coronavirus. The third part is the envelope, and we are going to see the structure of this envelope from chemistry's perspective. As I told, this envelope part is very important for coronavirus because it is its protecting cell. It is like a cover. Okay, so most of the chemistry is deal with this cover. If you see the structure of this envelope, it is a fatty acid chain. If you see the saturated carbons which are attached to each other, at the one end there is a carboxylic group. So this is a fatty acid lipid layer, and this lipid layer structure is a structure of the envelope, or we can say the protecting layer of the coronavirus. The last fourth part is a hemagglutinin ester dimer, and this ester dimer we can see closely from the chemistry's point of view. These are the small proteins which are attached to this envelope of this coronavirus. So this is the actual structure, and if you look more closely, they are nothing but the biopolymers of amino acid in different forms. So this is a helical form and this is a plate form. So, or it is also known as a sheet form. So basically this hemagglutinin ester dimers are the biopolymers of amino acids. Okay, so a chemist can look the coronavirus structure in such manner. So here is the complete structure of this coronavirus. As we discussed, this spike glycoprotein is the O-linked or N-linked amino acids. Then the inside the envelope RNA and N protein. Then envelope is a fatty acid chain, and this hemagglutinin ester dimer is the beta sheet or helical sheet amino acid chain. Okay, so this is what the chemist should see from the coronavirus. So as a chemist, we can see the detailed structure of this coronavirus in these four different parts. Now this coronavirus, as we know, currently there is no any medicines are available. So WHO have recommended several preventive measures to avoid its infection. So we are going to see what are the preventive measures which are recommended by WHO to avoid the spread of this coronavirus. The first is very important: clean hand or surface with soap and sanitizer. Second is to maintain adequate physical or social distancing. Third is use face mask or face cover. Okay. Because there is no treatment yet, so we can avoid the infection by following these three important preventive measures. Why we have to follow these preventive measures? To avoid the infection. Okay, so we can keep the virus away by using or by following these three important recommendations. So what is the chemistry, or what is the science, or what is the scientific rationale behind following these three recommendations from chemistry's perspective? We are going to see in the next part of this presentation. So basically this coronavirus is remain for different timeline on a different surfaces, and as we know, the lifetime is not much longer, but even it is not much less also. So currently there is no treatment. So what we can do, we can just follow the preventive measures to avoid its infection. So basically cleaning hands and surfaces, using face cover, and using social distancing are the important preventive measures. Okay, so we are going to see what is the chemistry behind these three important preventive measures of this COVID-19. So the first, I'm going to start with the chemistry behind destroying coronavirus by cleaning hand and surfaces. So how we can destroy the coronavirus, or what is the chemistry behind destroying coronavirus by using soaps or by using the sanitizer. So first is you can use a soap and water for cleaning hand and surfaces. So soap and water are suitable for both hands as well as hard surfaces. This is the structure of the soap molecules, which is a long chain of fatty acids. Okay, so the fats dissolve in a lipid layer, and this mm, carboxylate group which is dissolved in water. Okay, so we have to wash the hand for minimum 20 seconds to destroy the coronavirus. But how it works, or what is the chemistry behind this? Here we can see that how this soap and water destroy the coronavirus. The answer lies in the structure of the coronavirus. As we discussed, that this red color fatty layer having the structure which is exactly same like the structure of the soap molecule. So it is also the hydrocarbon chain with having carboxylic group, and the soap molecule also having the similar structure. So as per the principle of chemistry, like dissolve like, so this lipid layer of this coronavirus, which is known as an envelope or the protection layer of this coronavirus, get dissolved. It get break into a soap and water mixture, and that's why once the protecting layer get dissolved, breaks, coronavirus become deactivated. So this is the reason that soap molecule dissolve the fatty outside layer of the virus, and any type of soap is effective in this cleaning and dissolving the coronavirus layer. So it doesn't matter what type you are using, any soap which will have the basic chemical structure which is a fatty layer and which will contain the carboxylate group. So this is the first rationale behind cleaning hand and surfaces to destroy the coronavirus by using soap and water. Another way to destroy the coronavirus is the use of alcohol hand sanitizer. So alcohol hand sanitizers are suitable for both hand as well as hard surfaces. Basically, the most commercially available hand sanitizers contain ethanol and isopropanol. The minimum 60% alcohol are recommended by WHO for hand sanitizer and 70% for hard surfaces. So what is the chemistry behind the destroying coronavirus by using alcohol and hand sanitizer? The answer lies in its structure again. So if you look at the closed structure of this coronavirus, the lipid layer, again the envelope, which is fatty molecules, and we know this is an organic molecule, and ethanol, isopropanol are the organic polar solvent. The same principle is applied. The organic solvents are dissolving most of the organic molecule. So when we apply the alcohol hand sanitizer on our hand, the alcohol present in the sanitizer dissolve the fatty layer or the envelope of the coronavirus, and once the fatty layer get dissolved, the coronavirus get opened, and ultimately it get deactivated. So this way alcohol molecule dissolve the fatty outside layer of the virus and damage the structure of virus protein, and ultimately it get deactivated. The third way to destroy the coronavirus is to use bleach solution. Now bleach is not recommended for hands, but it is recommended for hard surfaces. Chemically, bleach is NaClO, means sodium hypochloride. This sodium hypochloride concentration should be minimum 0.1% solution to be effective against coronavirus. Here, one thing we have to remember that we don't have to mix bleach with other cleaners. This can generate a toxic chlorine gas. So how it works means how this bleach destroy the coronavirus. The answer lies in its structure. If you see the structure of the spike proteins of the coronavirus, this spike protein is the O-linked or N-linked amino acid to the sugar molecules. And if you see closely, this structure of the spike protein contain various oxidizable groups like CH2, OH, primary alcohols are there, CH2 groups are there. So these are the oxidizable group. And if you are chemist, you must have know that sodium hypochloride is a good oxidant. Okay, so this NaClO or sodium hypochloride is oxidize these oxidizable groups present in the spike protein. So when chemical structure is changes, the activity or the effectiveness of this coronavirus is decreases, and ultimately it become deactivated. So this way the bleach oxidize and destroy the virus proteins and genetic material, but it should be left on the surface for at least 10 minutes. So basically when you leave the sodium hypochloride on a surface, if on a surface there is coronavirus present, then within a 10 minutes this will undergo oxidation reaction of the crown proteins, and which is known as the spike proteins, and it will deactivate the coronavirus. The fourth way to destroy the coronavirus peroxide. Again, hydrogen peroxide is not suitable for hands because it is harsh. It is suitable for hard surfaces. Okay, this hydrogen peroxide should not mix with the vinegar. This makes a corrosive per acid. So what will be the percentage or concentration of peroxide in hand sanitizer or in cleaning material? It should be 0.5% minimum for its effectiveness. So how it works or how it destroy the virus? The answer is in its structures. Again, the same way, the spike protein is a O-linked or N-linked molecules to the sugar, and there are many oxidizable groups like CH2, primary alcohol, secondary alcohol. And as a chemist, we know that hydrogen peroxide is a good oxidizing agent. So when this hydrogen peroxide come in contact with the spike protein of the coronavirus, it start oxidation these oxidizable groups. And once oxidation start, the structure of the coronavirus spike protein changes, and ultimately its effectiveness or its harmness also changes, and it become deactivated. So basically this hydrogen peroxide oxidize and destroy the virus proteins and genetic material. It should be left on a surface for at least 10 minutes. So these are the 4 ways by which we can destroy the coronavirus, and this is the actual chemistry behind destroying the coronavirus by using these 4 means. So this was the first recommendation by the WHO to avoid the coronavirus infection, and this was the chemistry or scientific rationale behind using these first preventive measure. There are also other things which are used for the avoid infection of the coronavirus are the hand sanitizers. What are the hand sanitizers? These are the structure of the alcohols which are used in a hand sanitizer. Basically, the alcohol-based hand sanitizer contains 60 to 95% alcohols, and most contain either ethanol, N-propanol, isopropanol, or combination of these three alcohol. So basically, the chlorhexidine is the and benzalkonium chlorides are also found in some sanitizers. Both are also used in non-alcohol based sanitizers. So basically, some sanitizer also contain these two important chemicals, chlorhexidine and benzalkonium chloride. Along with this, other ingredients like glycerol is also present in hand sanitizer, which act as a moisturizer to stop your skin drying out. Okay, hydrogen peroxide is added to prevent the bacterial contamination in the hand sanitizer. So basically, your hand sanitizer contain mostly the alcohol, but in addition to the alcohol, there are other chemicals like glycerol for moisturizer purpose and hydrogen peroxide for prevent bacterial infection. So how the hand sanitizer works in destroying coronavirus? As we have already discussed the structure of the coronavirus, which contain the envelope. In envelope, there is a fatty layer, and the structure of the fatty layer is a long chain hydrocarbon which contain the carboxylic group. And when we apply the hand sanitizer, which contain the alcohols, the alcohol in hand sanitizer alter or denature, or we can say the change the structure of the proteins. They destroy the cell wall and membrane of the bacteria cell and the envelope of virus, including coronavirus. They are less effective against non-envelope virus. Non-alcohol based sanitizers also kill bacteria, but they are less effective against virus. So if we focus on our topic about the coronavirus having the envelope structure which is made up of the fatty acid chain, and as we know the sanitizer contain most of the alcohol, so that alcohol is work as a solvent to dissolve the fatty layer, and once the fatty layer get dissolved, the virus get deactivated. So how the effective are this sanitizer? The effectiveness is depend on the percentage of the alcohol present in the sanitizer. Minimum percentage should be 60%. They will be more effective if the percentage of the alcohol will be more than 60%, and they will be less effective if your hands are dirty or greasy. If you want the more protection from the coronavirus, first you wash your hands for 20 seconds with soap and water, and then you apply the hand sanitizer. So this will give you the double protection, because as we know, the lipid layer of this coronavirus, which is a fatty acid chain, will be first destroyed or dissolved by the soap and water, and again the alcohol present in the sanitizer will play the same role. So for better protection from the coronavirus infection, always wash your hands with soap and water minimum for 20 seconds, then dry your hand and then apply the sanitizer. This will definitely give you the more protection from the infection of the coronavirus. So this was the first preventive measures which are given by the WHO, and this was the chemistry or scientific rationale behind why we should wash the hand for 20 seconds, or what is the use of sanitizer in destroying the coronavirus. The second preventive measure, which was given by the WHO to maintain the social distance or to maintain the physical distance in the society. So what is the science or what is the scientific rationale behind the social distancing that we are going to see? The scientific distance or the social distancing is to maintain the distance between two people when we are in society. So basically, coronavirus travels in droplet expelled from the original host via sneezing, coughing, or just speaking process. These droplets will either evaporate quickly in the air or to be dragged by the gravity down to the ground. The majority of this droplet will land within 1 to 2 meters, because size of virus is nearly 150 nanometer, which will form a droplet of size nearly 1 micrometer. And because of the gravitational force, this type of droplets of nearly 1 micrometer will land within the 1 to 2 meters of the range from the host. This virus can only survive for a limited time outside of the host and need to get to the next host quickly. If host is standing within the range of travel by the virus containing droplets, then they have a high probability of catching the droplets and becoming infected with the coronavirus. So here we can see in the picture, this is the person which is infected by the coronavirus, and during the different process of sneezing, coughing, or just speaking, the coronavirus inside the mouth try to come out, which is having size of nearly 150 nanometer, but when it come in outside, it form a droplets, and that droplet become nearly 1 micrometer size. And because of this size, they have some mass, and because of this mass, due to the gravitational force, this will land in different range in 1 meter, 1.5 meter, or 2 meters. So depending on the size of the droplets, they can land in different distance. That's why you should always maintain an adequate physical or social distancing. Okay, so it is now recommended by WHO that you should maintain a 2-meter social distancing. Previously it was mentioned 1 meter social distancing, but now it is suggested that 2-meter social distancing is very important to avoid the coronavirus infection. So this is the science, or this is the scientific rationale why we should maintain the social distancing, but to avoid the coronavirus infection. So if a droplet size are small, they can travel a large distance. If droplet size is large, they can travel a small distance. So that's why the distance is suggested at least 2 meter to avoid the coronavirus infection. So this was the second recommendation of the WHO for preventive measures of the coronavirus disease, and this is what the scientific rationale behind the social or physical distancing. The third important recommendation is the use of face masks, and they are known as a today's weapon against COVID-19. So as we know, in market there are various masks are available. Simple cloth mask, even in news was there are silver masks are developed, and now there are gold masks are also developed. So there is definitely no need to use the silver or gold mask. A simple fabric mask is sufficient to protect against this COVID-19 infection. There is an interesting research article which was published in this ACS Nano in April 21, 2020, entitled Aerosol Filtration Efficiency of Common Fabric Used in Respiratory Cloth Mask. And this research clearly comes with the conclusion that the common multi-layer fabric mask is good enough for protection against COVID-19 or protection against coronavirus infection. Here are the outcomes of their research. They have used the multi-layer mask, and they propose that the first layer is the filtration of the particles by mechanical filtration, and the inner layer filters the remaining particle by electrostatic filtration. These are their outcomes, that they have carried out these studies for several common fabrics, including cotton, silk, chiffon, flannel, various synthetic, and their combinations. Although the filtration efficiency for various fabric when a single layer was used range from 5 to 80% and 5 to 90% for particle size of less than 300 nanometer and more than 300 nanometer respectively. So if size is more, efficiency will be more. The efficiency improved when multi-layer were used and when using a specific combination of different fabrics. So this is also important observation, that multi-layer gives the better efficiency. The filtration efficiency of the hybrids such as cotton silk, cotton chiffon, cotton flannel was more than 80% for the particle less than 300 nanometer and more than 90% for particle more than 300 nanometer particle size. So this is also clear that efficiency increases if particle size increases. They speculate that the enhanced performance of the hybrid is likely due to the combined effect of mechanical and electrostatic based filtration. So as I discussed earlier, they have proposed that the filtration efficiency is due to this combined effect of the mechanical and electrostatic based filtration due to the hybrid composition. Cotton, the most widely used material for cloth mask, perform better and can make significant difference in filtration efficiency. So that's why this I want to highlight that there is no use of, or there is no need to use a silver or a gold mask for the protection. Simple cotton fabric mask is sufficient. Their further observation that the study also implies that the gap, means the improper fit of the mask, can result in over 60% decrease in a filtration efficiency. So this is very important observation, and this is very important that you should fit your mask properly to the face for maximum protection. If your mask is not properly fitted, then there will be less than, there will be decrease in 60% efficiency of the particular mask. So you should properly fit your mask to the face so that it can give the better result. And overall, their conclusion that they find the combination of various commonly available fabric used in cloth masks can potentially provide significant protection against the transmission of aerosol particles. So particularly, they focus that the cloths or the common cotton cloths are sufficient for getting the protection. Many research papers have been published on this area in this last 6 months of the COVID. Thousands of papers have been published in this particular area, and currently this is the hot topic in a research which is concerned from the chemistry point of view, that how we can get the protection, what PPE we can develop, or how chemists can be involved in this type of research to get the more protection to the people. And like this, one of the researcher which is from the University of Mumbai have done an excellent research, and they have achieved various good observation in this COVID-19 research. Dr. Vishwanath Patil, Associate Professor, Department of Chemistry, University of Mumbai, they have developed a nanotech-based antiviral coatings for application on PPE and N95 face mask to kill virus. So this is what the chemist role in this, or the researcher role in this COVID-19 pandemic. It will prevent any kind of infection and help save the life of the medical staff and frontline worker in COVID-19 pandemic situation. So this is the research opportunity or the current research area for the researcher which is working in the same line, that they should develop a material which will give the protection against the medical staff, or they will give the protection against the COVID-19 or coronavirus to the various people which is actually working in this field. So here is the photograph which shows their recent achievement and the media highlights about their recent achievement. So this is actually the research which is going on currently in the field, which will provide the protection to the many peoples, and it will save the lives of the many people. So this way we have covered the various chemistry aspect in the context of preventive measures of the COVID-19. We have explored the structure of the different parts of coronavirus from the chemistry's eye. We have explored the chemistry of the hand sanitizer, hand surface cleaning. We have explored the chemistry of the cleaning of the hand by using soap and water. We have also explored the scientific rationale behind maintaining social or physical distancing to avoid the infection of coronavirus. And we have also explored the effectiveness of face masks and the current development in the research in the PPE and face masks. So all these are the preventive measures which were recommended by the WHO to avoid the infection of the coronavirus. So basically, the three main recommendations given by the WHO to avoid the infections are wash hand and surface, maintain social distancing, and use face mask or face cover. And this is what the scientific rationale behind this following these three recommendation of the WHO to avoid the coronavirus infection. So nowadays systems are started, but in middle of this month, May or April, the country was like this. The roads were empty. there was a very decrease in pollution line also. And when roads are empty, the place were taken by the animals. But now slowly unlock has started, and people are started going to start their work. So soon everything will be normal, and we will go to our normal life. Till then, you take care of yourself. Follow these three important recommendation of the WHO to prevent the coronavirus. And I take this opportunity to acknowledge my mentors, Dr. Ganesh Thakur Sahib, Principal, Mahatma Phule ASC College Panvel, Honorable Dr. J.G. Jadhav Sahib, Principal ASC College Mokhada, District Palghar, Dr. D.R. Nagargoje, Head Department of Chemistry, ASC College Mokhada, District Palghar, Dr. Vishwanath R. Patil, my mentor, Associate Professor, Department of Chemistry, University of Mumbai. I also thankful to Dr. Rupashri Kadu, co-coordinator of this webinar and Assistant Professor, Department of Chemistry, ASC College Mokhada, District Palghar, and I acknowledge all the members of the organizing committee of this webinar for their grand success and giving me opportunity to deliver my knowledge in this particular area. Thank you very much, and thanks a lot to all of you.
Thank you, sir. Thank you very much. Sir has given a wonderful and informative information on working mechanism of hand wash, hand sanitizers from chemistry point of view. I'm sure it makes awareness in this pandemic situation of COVID-19. Thank you, sir. Now we move towards the question answer session. One question. Hello, sir.
Yes.
One question from the participants. If we use antibacterial nanoparticle coated mask outside, then will it kill the virus?
Definitely, if you saying that it is antibacterial, it will not going to be affect, because there is different mechanism of bacteria and virus. As I mentioned in one of the slide, that antibacterial will not affect. Antiviral will affect, because corona is the virus, not the bacteria. There is a different structure of virus and bacteria. So basically, the antibacterial coating may not work properly. It should be the antiviral coating.
Okay, thank you, sir. Now I request Professor Arekar, sir, to continue the session. Over to you, sir.
Thank you, Dr. R.K. Kodu, madam. Thank you, Dr. Thakur, sir. Now, I request Dr. Gadi, sir, to deliver speech of thanks, vote of thanks.
Hello everyone. A warm and graceful good afternoon to all. On behalf of Department of Chemistry and Physics, Art, Science and Commerce College, Mokhada, it's my privilege to take this opportunity to propose vote of thanks for this national webinar. At the outset, I would like to thank our resource person, Dr. Mahesh Badane sir from Dada Patil Mahavidyalaya, Karjat, for sharing a valuable knowledge on luminescence, a brief overview and thermoluminescence dosimetry with our participants. I'm also thankful to Dr. Pramod Thakur sir from Mahatma Phule Art, Science and Commerce College, Panvel, for giving a deep knowledge regarding chemistry aspects of COVID-19 pandemic to our participants. I hope that both these topics will be very much useful for our participants. I would like to express my sincere thanks to our Honorable Principal Dr. J.G. Jadhav Sahib for giving a nice opportunity and a constant support on the occasion of national webinar in this COVID-19 situation. I'm also grateful to Vice Principal Professor S.E. Sendanshu sir for their kind help and support. I am very much thankful to our Vice Principal Professor J.B. Wargade sir for their technical support and teaching and non-teaching staff of Art, Science and Commerce College Mokhada. I'm also thankful to our IQSC coordinator, Dr. A.B. Mamlaya sir, coordinator of the webinar, Dr. D.R. Nagargoje sir, co-coordinator, Dr. R.K. Kadu madam, convener of this webinar, Professor S.K. Whitnor sir, co-convener, Professor S.A. Funde sir, anchor of the today's webinar, Professor D.H. Arikar sir, and the whole success for this event goes to our organizing team for organizing such a nice event. I thank everyone who helped to succeed this national webinar more effectively. Finally, I would like to express thanks to our participants for attending this national webinar. Thank you so much once again. There is short notice. Participants, please fill the feedback form. The link will be shared shortly on the Telegram group. First 100 participants will get the certificate today. Remaining participants, please try to fill the feedback link tomorrow or day after tomorrow if you don't receive certificate. Link will be active for next 3 days. Okay, so with prior permission from the organizers, I declare this national webinar is over now. Thank you.